Good evening, Doctor. I'm called Asima Brenda. Today I'm going to be taking you through the visualization I did using Tulip. So first of all, I downloaded my data from Cargo. It was data for different airplanes. So the data had different fields, which was airline, then the ID, then the source airport, ID, then the destination ID. Then there was code. Okay, I honestly don't know what these other fields are, but they're not even going to be useful. The code share, number of stops is how many times the airplane stops, and we had zeros throughout. Then we have the equipment. I also don't know what that is, so I really didn't, put it in my field. So before even putting this data into Tulip, I kind of, should I say, cleaned my data. I divided it up into nodes and edges. So first of all, we're going to look at the nodes. So for the nodes, I just got the data that, like, using the source airports and the destination airports. I just copied all the source and destination airports and I pasted them here. And then I removed out the duplicates, which left me with about 98 fields, 98 airports. Then I gave them IDs. So since I didn't have the names of these airports in full, I had to improvise. I had to use Google to get their names in full, and then their country and the longitudes and latitudes. For I had to use them, like, to get them personally. So that is the data that I used as my node data set. And then for edges, when I went to edges, I got the source, like in the original data set. I put the source, the target, the airline. I gave the airline also an ID, unique ID, so that because there are some visualizations that require integers or doubles. So I also had to come and give these airlines the what? These unique IDs. So yeah, that's about the data set. So before that, I had to come up with some of the questions, and which questions were, so first of all, this just was giving a brief about the purpose of the whole visualization and all of that. Then I also had the description of the data, which I've just taken you through. Then I asked myself the questions of how are airlines distributed geographically. So now this is going to lead me to the different data sources. I mean, the different graphs that I used. So asking yourself, how are airlines distributed? Are there noticeable patterns? Distribution between flights, like the origins? Are there more airlines in the when leaving the source, or like, just these are questions I came in with. So maybe I will go through them as I also look at the visualization. So this is the graph. These are the graphs I managed to come up with when I imported the data. So I think we shall start here. When I imported the data, it brought me this. It created for me these nodes. So I had to go and change their color so that according to the airlines, that's when I told you about I had to give the airlines unique IDs. So now this is where the unique IDs come in, because now it helps us see, because this in red is a different airline. So you'll notice that this in red, the airline only uh, sets off, and like the source and destination are within this area. It doesn't really go into other areas. So, and then this was the pattern for also another airplane. Then this was also a pattern for another. So we shall get more into it when we look at the geographical. So maybe we shall look at the questions while we look at that. So they said, I asked how are airlines distributed geographically, and are there noticeable patterns of airports operated by specific airlines? So when you look at the data set, we shall have to go to the geographical data, and then you notice these are the different patterns for the. This is one different airline. This is one different airline. This is one different airline. But are they connecting? Yes, because you notice this airline in red, which in yellow. Oh, since they're here, you notice the airline in airline 2B and 2G. At least they have some different airports that they share. For example, this OVB and CEK. I'm sorry, I'm going to talk about the airlines in short because I don't want to keep going back to the data set to see which ones they are, and I really don't know them in full. But you'll notice at OVB and CEK, they share airports. So you find airline 2G and 2B land both here or settle from here. Use it as a source and destination. These two. Then the second question was noticeable patterns. So for noticeable patterns, you notice the specific airline to be mainly goes to Africa, Asia. It's not so much in Europe. Is it? Oh, no, this is Middle East, Asia, and Africa. Then you'll notice 2I is in this area specifically. So it is like these airlines operate in specific regions, or should I say countries. It's not like they operate all over the globe. Then they said which airports serve as major or have the highest incoming on outgoing flights. So now there we shall have to look at the histogram, because when you look at the histogram, we had the values of the sources and targets. So when you come here specifically, remember we had different airlines that have, so that we gave different unique IDs. So the airline one here, which was let me just go there briefly, if you don't mind. Airline one, which was, airport A, which is AER, is right here. So basically, it's only one airplane that sets off um, from this airport. There's only one that set off from there, and then on two airport two, there are two planes that set off from there. While airline one also has one specific airline that lands there. So that is just looking at the distribution of which airport, how many planes land in a specific airport. So yeah, like when you zoom in, seven, we had about also one. It's also one setting off from seven. Well, also one sets in seven. So you just look at it like that. Then when we move on, if we move on, you look at so anyways, these questions were kind of guiding me when I was, creating these graphs. So maybe just to save some time, I will just take you through the graphs I came up with. I came up with this, which I talked about, the histogram, looking at how many uh, on airports have flights in the source and in the target. Then I think I've also looked at this. The other challenge with this geographical data is however much I try to get coordinates, I even used different AI tools to try to get coordinates for these specific airports, but they don't seem to be accurate. You find, like, if you zoom in so much, you find this airport is showing in water. So I tried it so much, but that's what it kept doing. So I don't know if it's the inaccuracy of Tulip itself or it's a problem with the data set. But that's the pattern it brought me, which also matched the other first pattern. Then this parallel graph is just showing me patterns between the source and the target. So I'll just zoom in to make some things a bit clear. Like when you look at AEA, AER is the airport, source airport. So 2B sets off from AER, and also lands can land in AER. I mean in KZN. These are the ones it lands in, but also AER is among them, the ones it sets it lands in, and also among the ones it sets off from. So these are the ones it's setting off from. So just shows you which the patterns of the different airlines, where there's which one sets off from which specific airlines, and which one sets off in lands in which specific airlines, and if they are shared. Just like you see here, 2B and 2G share some specific airports that they land and set off from, but then the rest don't seem to be sharing them, and we also saw that in the graph here. And then this was just showing the distribution. Okay, this I can't explain this so much, but this was just showing the distribution of the airlines. Can't talk much about that one. Then this scatter plot is showing the also distribution between source, airline ID, and so when I zoom in, you notice airline ID. We gave them unique IDs, which was 1, 2, 3, 4, 5 up to 9. That was for those airlines of ABCD. No, 2G, 2I, things like that. So in the source, you'll notice the one which was given 1, and that was 2B. 2B is 1 and 2G is 2. 2B is 1, 2G is 2. So you'll notice this one is 2B and 2G. So airline 1 lands off from basically more of these airports, and then airline 2 is, which is 2G, is more in these airports like that. Same for the source. But then now here talks about the target, the distribution between the target and the source. So that is why we noticed, we already talked about it, that airline 1 airline 1 is between this lower one, so that is why it gets distributed around there, low there. So its distribution is between 1 and, I think, 1 and 17. So that is why its coordinates are in there, they are mapped in there around there. So just like that, you'll notice these other ones, the airlines, the purple one, which is 7, is around here, which is around 49 to maybe 70. So that is why it's scattered around here in this area in these areas. So for the last graph, I had this, which is called the, what is it called? I've forgotten its name. Adjacency matrix. So in the adjacent matrix, we kind of have to zoom in to make things more seen. So basically, this graph shows the distribution of airports where a sets off and where a flight sets. So when you notice here, this flight, the one in yellow, which was what? I'm sorry for taking us back. Yellow was 2B and black was 2G. So yellow is 2B. So let's just look at yellow so that I don't forget. So yellow, which is 2B, sets off in AB, ABR, I mean AER, and lands in KZN. So the reason why this is shaded yellow is because this is a direct flight, meaning a flight does not have to stop at a specific airport before it goes to another airport. So for example, this 2B is shaded here because the flight leaves AER, shades sets off in KZ. So now this column here is for KZN, and this one is for AER. This whole row here is for AER. So all planes that leave this row will, and maybe set in a land in an airport here, that column will also be shaded. So that is why this one is shaded. So you find a plane leaves OFK and then lands in, sorry, CEK and lands in CVB. So now we have to look for the column. This column, now we have to look for the row which is here, CEK. So since it leaves CEK and lands in OEV, that's why these two are shaded. Like CEK is here, OVB is here. OVB is here, CEK. So when they get shaded, when there is they share like where the direct flights, I think. I don't know if that's clear, but yeah. So that shows that this comes from here. Then there's also a pattern for KZN and ASF, ASF and MRV. And there's also a pattern of KZN, CEK. And then there's a pattern of CEK, CO. Now, when you notice this, these are two different flights. So let's assume someone was going to OVB, airport OVB, and they are at AER. That means they'll have to go from AER to KZN, and then from KZN they'll have to go to CEK, and from CEK that is when they'll be able to reach their destination that they're finally going to. So that is what I interpreted from my work here. Yes, thank you so much, and that's what I have for you. Thank you.